Okay, so today we did a combo lesson, but it was all about vertex form. So for those of you that have not had the lesson yet, you might want to write this down. But the vertex form is another form of our quadratic functions. So each form has its pros and cons. Guess what you can see really clearly from the vertex form? The vertex, all right, it's in the name, just like slope intercept form. In that form, you can really see the slope and y-intercept. Things like that. Okay, so it's in the name, what you can easily see from it. And that equation is y equals a parentheses x minus h in parentheses squared plus k. So again, if you haven't had the lesson yet, you might want to write that down. A is really the same as it was when it was compared to our standard form, ax squared plus bx plus c. You know that certain changes to the A affect the graph in certain ways, like it could make a vertical stretch if it's a number greater than 1 or less than -1 that you're multiplying it by. It can make a vertical compression if it's between -1 and +1. And it can also be a reflection if it's negative. So same thing we learned yesterday. If you change the A, it could result in one or even multiple of these changes. Then we have the H. So in vertex form, the HK paired gives the vertex. Everyone should be listening, headphones out, like some of you have never learned this. All right, HK is what our vertex is. So any change to the H or there being an H would shift the graph either left or right. So if it's moving to the left, that would look like x plus a number in parentheses squared. If it's moving to the right, it looks like x minus a number in the parentheses squared. And then any changes to the K would be up or down movement. And that one's pretty easy. It's kind of like the C in our standard form. If it's positive, it moves up. If it's negative, it moves down. The one that's kind of confusing is the H. And maybe we'll do a couple of examples, but that's the one that has the opposite sign of how it looks in the equation. So that's why I put it's going left if it says x plus a number. It's going right if it says x minus a number. Okay. So that I'll leave up, but I'll probably have to show you a few examples first, but you should be able to recognize the vertex form when you see it and relate it to the graph. You should be able to tell me what the vertex is without necessarily needing to graph it. Obviously on a test, you can graph it and look at it, but that's the whole point of vertex form, and you shouldn't need to. So your goal today will be 80% or higher on this one. I'm starting to enable it in the other classes that it might not be enabled in yet. Additionally, if you're in my class, you have a binder check coming up. So when and if you finish early, get that together. Any note sheets will be in this bin, including the coloring activity that is almost due soon. I also have set out the practice constructive response test. I'm giving that to all my algebra students today. If you want it early, go ahead and grab it. So that's something else you can work on when and if you finish that practice early. So there's that. Let me show you, I promised a few examples of the vertex form. Let me add something in here. Okay, So knowing that, and I'll put it up here as a reminder. Knowing that our vertex is HK, think about what the vertex is if this is the equation you're given. Think about it, don't say it yet. Okay, table 7, what was the vertex for this? If this is my equation and we know HK is the vertex, what's my vertex? 4, -2 is correct. So H is always in parentheses with the X, K is always after the X squared. So this is my K. H always is the opposite of how it looks in the problem. Because if I'm plugging in a +4, so this is my H, into the equation, that's how it looks. I'll show you the negative one so that you can see why it changes to positive, but that's my H, a +4. The K always matches the sign that's shown. Okay, so I'm gonna write another one up there. So this -2 doesn't affect it. I mean, it does, it will open downward and it'll make it more narrow, but that has nothing to do with the vertex if there's a number in front of the X squared. But here's another example. Okay, think about what the vertex would be, knowing that HK is our vertex. Okay, table 2, what do you think? Yeah. -1, +3 is my vertex. All right, so this time H had to be a -1 if it became positive. Because this is what I'm plugging into. I end up with a double negative. And what happens with a double negative? That's why it looks opposite of what the other side of it is. And then this always matches. Okay. That's basically the gist of what we learned today, is how to read vertex form and so forth. I think I'll go back to the other slide I had that had what each letter does to the equation. So then know that if you saw, for example, no number in parentheses with the X, then H must have been 0. Or if you see no number added or subtracted on the end, then K must be 0. Okay, so know that too. Our parent graph has a vertex of 0, 0. So I'll leave this up for a second. I'll go back to the other page, but the goal is to get 80% or higher on the 15-16 practice. Mine is combined into one. Your other teachers might have it separate. If they call it just 615, that's totally fine. That's the one that we're trying to get 80% or higher. I'm gonna make sure it's enabled for everyone, but any questions right now? Yes. So number 2 on today's practice, if you also needed help with it. It says that the following 2 equations are equivalent. What form is on the left side? When it looks like x times x plus 6, what do we call that format? Standard is where it's all simplified and you can't multiply anything out. And this one I can distribute, so it's not standard form, it's vertex form is this one. Because vertex form. So then this one on the left must be factored form. There's pros and cons to each form. So in factored form, what's really easy to see the x-intercepts. So in this one, I can easily see my zeros. In vertex form, it's really easy to see. The vertex. That's why we call it vertex form. In standard form, which is not on this page, but standard form, you can easily see your y-intercept, okay? Now, this one says which one would be easier to find the vertex. That would have to be the one that's in vertex form, so P of x. And then it said, what is the vertex? So based on what we know from vertex form, our vertex is HK. So out of these options, the 3 has to be positive or negative. And there's only one option that even has it like that. So yeah, the H is always opposite of how it looks in the equation. So if it looks positive, it's actually a negative that they had to plug in. But the K always matches. So that's my vertex. Which one would be easier to find? The x-intercepts, the one that's in factored form. And then what are those x-intercepts? So looking at our factor form, what are our x-intercepts? Zero, zero, and -6, 0. And the reason why, because I remember we had you guys just kind of memorize patterns at first. But the reason why is because at the x-intercept, y equals 0. So if I set this equal to 0 and I have something times something else, in order for it to multiply to give me 0, one of these would have to be 0. And it could really be either one. So the way that you actually solve for your x-intercepts is you set each factor equal to 0 and solve them separately. That's why there's usually 2 x-intercepts. So on this one, it's already solved. X can be 0 and that'll meet it being at 0. Or it could be, so isolating the x, it could be -6. Plugging in a -6 for the x would make the final answer 0. So that's why there's usually 2. Okay, so questions on that one? Questions on any others? Rita? Sit on today's topic? Does it say describe what would happen? Okay. So describe what would happen if the original equation were modified as follows. And they're telling you the original equation is x squared, our parent function. But if it was modified to where we change the a to negative, that would stay or flip the graph. It would flip it to open. If it's negative, does it open up or down? Down like a frown, it kind of rhymes. And also like negative things make you frown. So if it's negative, it opens down. So it opens downward. And will it still have the vertex in the same place? It will. So changes to the A don't make it move up, down, left, or right. It either makes it wider or narrow, or it flips it. Okay, so it'll still have the vertex at the origin. You could also graph it and compare too, but just by what we've observed, we know it's going to be that. Now, if it's 3x squared, so now we're making the a of 3, would the parabola become more narrow or more wide? More narrow. And you could graph it and see that. But we saw that if it was greater than 1 or less than -1, it made the graph skinnier. So it would be more narrow so that it forms a skinnier shape. Last one, it's x squared plus 6, so we're changing, and you can think of it two ways. We're changing the c in standard form, or we're changing the k in vertex form. Both have the same effect. Adding 6, does it move it up or down, or left or right? It moves it up, because it's after the squared part. And then even if it was in the parentheses with the x, if it was plus, it would actually move it through. So when in doubt, graph it and see the change. It told you the parent graph is x squared. So you can see like how it's moving, in what direction, and all that stuff. So good on this one. Make sure the key is right, and it is. Rebecca, did you have a question? Number 7. So number 7 on today's, we are matching each graph with the quadratic that it represents. So they're all different from the parent graph, it seems. Only one of them opens downward, so I'll start with that one. The one that opens downward should have a what? A negative x squared. So, and there's only one, because there's only one that opens downward. So I know this one goes with graph C. The one that's a negative x squared. And then out of the others, we have one shifting right, one shifting left. I'll save those for last. This one's going down. So remember what made things go up or down? That was a change in the K. So like adding a number at the end or subtracting a number at the end, or the C, if they have the same effect. So which one shows shifting down 3? Good. And there shouldn't be anything else like with the X, because it's not moving left or right from our parent graph. So that is also kind of an indicator. These other ones are in factored form, so I'm gonna go based off of the zeros or the y or x-intercepts. So for this first one, what would my zeros have to be? Good, -1 and -3. So the one that has it, the x-intercepts on the negative side, goes with this one. So let me find it. It would have to be this graph B. Because remember that x-intercepts are always like opposite sign of your factored form. So then process of elimination, the other one must go with graph A. One that has x-1 and x-3. Because both of those zeros would then be positive. So good testimony. So good on this one. I might have time for one more, depending on how long it is. Number 4 on this one. All right. So it says for each equation, write the coordinates of the vertex of the graph that represents it. And they're all in vertex form. So let's rewrite that equation up here, where HK is your vertex. So the number that's in the H position and the K position is what we are looking at. And remember how it looks in the equation for the H is always opposite. So the vertex for this first one should be what? Three, and then 5. So the K always matches the sign. The H is always opposite how it looks. Then for the next one, for B, there's a number in parentheses with the x squared. Can you guys not talk? Thanks. The H is always opposite how it looks, so what should my H be? A positive 4, what should my K be? 0, because there's nothing added or subtracted. C, x squared minus 1, there's nothing in parentheses with the x, so that means my H is what? And then what's my K? Good. Last one, I think, I don't want to scroll because I don't want to mess it up. But if it looks positive in the equation, my H is actually negative, and then my K will be the same sign that it looks. Does that make sense? Okay. If not, you know, just ask me later, but